Welcome everyone. In this FinDaS module, we're diving deep into the world of tokenomics and Web3. Our goal is pretty straightforward, to give you a solid foundation in this space, but more than that, to hand you the tools you need to analyze any token-based system you come across.
So here's our game plan. We're going to start with the absolute bedrock, blockchain fundamentals. From there, we'll build up, talking about tokenomics and the core idea of decentralization. Once we have a framework for how to think about tokens, we'll put it all to the test with two really important case studies, Bitcoin and Filecoin.
All right, let's jump right into section 1. Before we can really get our heads around tokens, we first have to understand the world they live in. And that world is built on a really unique kind of data structure, the blockchain.
At its very core, a blockchain is just a special kind of database. You can think of it like a digital ledger book. It's this ordered, always growing list of blocks that are all linked together securely. The really key features are immutability and integrity, all thanks to some clever cryptography. But here's a super important point that a lot of people miss. A blockchain by itself is just a data structure. It's not automatically decentralized. That part comes from the consensus rules we build on top of it.
Now, this is where it gets really interesting. Look at how this slide visualizes that cryptographic link. If you look closely at block B, you'll see a field called previous hash. Well, that value is the unique fingerprint, the unique hash of block A, and block C, in turn, contains the hash of block B. This creates this unbreakable chain. If someone tried to go back and change the data in block A, its hash would completely change, and that would break the link to block B and every single block after it. It makes the entire history of the ledger impossible to tamper with secretly.
So, now that we've got that technical foundation in place, we can start to explore the economic engine that really makes these networks hum, and that field is called tokenomics. You hear this term everywhere in the Web3 space, right? But its meaning is often misunderstood, and honestly, it's way deeper than most people realize. It's really the art and science of designing entire digital economies from scratch.
So here's the bottom line. Tokenomics is all about designing rules and incentives directly into the code of a network. Think about it. In a world with no central authority, no CEO, no board of directors, how on earth do you get thousands of anonymous people all over the world to cooperate and secure a network worth billions of dollars? Well, you do it through a carefully crafted system of rewards and penalties, all managed by the network's own token.
And this brings us to probably the single biggest misconception about this entire field. A lot of people see a chart just like this one, who gets what percentage of the supply, and they think, yep, that's tokenomics. And while that allocation is a piece of it, it's just one small part of the story. True tokenomics is the entire underlying architecture, the rules for how new tokens are created, what you can do with them, and the game theory that makes sure everyone is incentivized to act in the network's best interest. When they're designed well, tokens are kind of like these incredible multi-tools. They can incentivize validators to keep the network secure, they can act as a native currency for exchange, they can contribute to security through things like staking, they can even enable community governance through voting, and of course they can represent unique things, like with NFTs. This brings us to a really core philosophy of Web3, decentralization. You could say if blockchain is the what and tokenomics is the how, then decentralization is the why.
So in this context, decentralization really means two things. First, it's permissionless, which means anyone with an internet connection can jump in and participate. No one can block you. Second, it's trustless. Now, this doesn't mean there's no trust. It just means we shift our trust away from a single company or person and onto transparent, verifiable code. The truth is established by the whole group reaching a consensus.
This actually brings us to a classic problem in computer science, which is visualized here as the Byzantine generals problem. The puzzle is this. How can a group of generals surrounding a city all agree on a plan of attack if some of them might be traitors sending bad information? Well, blockchain consensus mechanisms provide a solution. They allow the network to agree on the truth and keep working even if some of the participants are malicious. This amazing property is known as Byzantine fault tolerance.
But as elegant as these systems are, the people who design them face a massive fundamental trade-off.
It's known as the scalability trilemma. And what it says is that you can typically optimize for any two of these three things, security, scalability, and decentralization, but getting all three at the same time is an enormous engineering challenge.
And this graphic just brilliantly illustrates how different projects deal with this trilemma. Notice how Bitcoin and Ethereum are planted firmly on the side connecting security and decentralization, and they've historically sacrificed a bit of scalability to do it. Other projects might lean the other way, maybe compromising a bit on decentralization to get higher transaction speeds. There's no single right answer here. It's all about design priorities. To help us make better sense of how all these different tokens work together in the ecosystem, it's really helpful to use a simple 3-layer framework. This lets us categorize them based on where they live and how they're issued. I want you to think about this framework like we're constructing a digital building. At the very bottom, you have Layer 1 tokens. This is your concrete foundation, the native crypto of the base blockchain, like Bitcoin or Ether. Then you build on top of that with Layer 2 tokens, which are like the floors and infrastructure that help the building scale. And finally, at the very top, you have protocol tokens. This is the furniture. These are the tokens for specific apps that run on the layers below.
This table gives us a really clear side-by-side comparison. Just notice how the function shifts from pure infrastructure at Layer 1 all the way to a business focus for the application tokens. And in the same way, the value drivers change, from being the core currency of the whole network to being tied to the specific usefulness of a single application. This distinction is absolutely vital for doing proper analysis.
All right, now that we have our frameworks in place, let's apply these concepts to the one that started it all, the first and most famous cryptocurrency, Bitcoin.
21 million. If you remember one single number about Bitcoin's tokenomics, this is it. It is the hard-coded, unchangeable, absolute maximum supply. There will never, ever be more than 21 million Bitcoin. This idea of absolute, provable scarcity is the very foundation of its value proposition as digital gold.
Now, from a user's perspective, the process is actually pretty straightforward. You create a wallet, that gives you a public address to receive money and a private key to send it. You sign a transaction with that private key and you broadcast it to the network. Behind the scenes, this global network of miners validates your transaction and cements it permanently into the blockchain.
Of course, these design choices lead to some very distinct trade-offs. The advantage is you get this incredibly secure and truly global bankless system. The limitation, which really comes from that intense focus on security and decentralization, is that its proof-of-work system uses a lot of energy and it just can't process transactions as fast as a centralized network can.
So, let's just quickly summarize the key tokenomic pieces here. We've talked about the fixed supply. New Bitcoins are created and given to miners as a reward for securing the network. And this is critical, that reward, the block subsidy, gets cut in half about every 4 years in an event called the halving. This creates this perfectly predictable disinflationary schedule. And it also had what's called a fair launch, which means the founder didn't take any special share for himself. Every single coin had to be mined into existence.
This predictable decline in the reward brings up a huge long-term question for the network's security. I mean, if the subsidy that pays the miners eventually goes to zero, why would they keep spending energy to secure the network? Well, the answer is actually coded right into the system. Transaction fees. The design anticipates that as the network gets older and more people use it, the fees paid by users will eventually take over from the block subsidy as the main reason for miners to stick around.
Okay, now let's pivot and look at a completely different model. If Bitcoin's tokenomics are all about securing a ledger of monetary value, Filecoins are designed to secure something else entirely: digital data. The big vision for Filecoin is to create a decentralized open marketplace for data storage. So instead of having to rely on big centralized cloud companies, you can pay people in the Filecoin network to store your data for you. The Phil token is the currency that makes this whole marketplace work, paying for storage and giving providers a reason to be reliable.
This diagram shows you the core loop. A user pays a miner in Phil. The miner promises to store the file. Then, and this is the really clever part, the network uses constant cryptographic proofs to basically check up on the miner to make sure the file is still there and stored correctly. It replaces trust in a single company with verifiable mathematical proof.
Now, unlike Bitcoin's fair launch, Filecoin's initial supply was allocated to different groups. This is pretty common for complex protocols that need a lot of upfront development. But what's really crucial here is that you notice the biggest slice of the pie, 70%, is reserved for future mining rewards. This creates a massive pool of incentives to attract storage providers and grow the network's total capacity.
The genius here is really the elegant mix of incentives and penalties. Miners get rewarded for providing storage, sure, but they also have to lock up FIL tokens as collateral, like a security deposit. If the network catches them failing to do their job, like if they lose data, their collateral gets slashed, meaning it's taken away. This creates a really strong economic reason not to misbehave, which keeps the network reliable. Plus, burning fees adds a nice deflationary pressure on the token supply.
And this quote just hits the nail on the head. You see, technologies like the Interplanetary File System, or IPFS, gave us a way to address data decentrally. But Filecoin added the missing piece, a powerful economic layer. It provides the incentives that make decentralized storage not just technically possible, but actually economically viable and reliable on a global scale.
Wow. Okay, so we have covered a ton of ground here, from the deep technical details of a blockchain all the way to the high-level economics of token systems. We've seen how these principles can secure money with Bitcoin and how they can secure data with Filecoin. Which leads us to one final, really important question.
We've seen these incredible systems designed to secure monetary value and to secure digital data. So what's next? Maybe they'll secure our identity, or computational power, or even scientific discoveries. The design space is absolutely vast, and understanding the fundamental principles we've discussed in this module is the key to both analyzing the systems we have today and anticipating the amazing innovations of tomorrow. Thank you.
If you're ready to go from theory to practice and apply this blueprint to your own project, please visit us at FinDaS.org. We have more in-depth materials and token design support waiting for you.